everyone. Welcome to the sig-testing meeting. First off, just to start, if there's anybody who is new to the meeting and would like to just go ahead and unmute and give a brief intro for yourself, feel free to do so.
Hi guys, I'm Peter Kramer. I'm based in Rotterdam. I'm a longtime Kubernetes user, and I'm looking to start to developing. I'd love to become part of the community and to contribute. And since it appears to me that this SIG focuses or touches every part of the project through the infra, through the SIG, through the CI/CD, that's what kind of drove me here.
Welcome. And then same if anybody else would also like to.
Can I? Hi guys, my name is Leo. I live in New York, and I try to find a way to work with you and this community. I think it's a good chance to help this project because I have 10 years experience in IT, and I look in something more interesting because I'm a little bit tired of usual business tasks.
Welcome. Cool. Good to have y'all. And I think with that, I also see some familiar faces here. So let's go ahead. Patrick, I think you have the first couple items if you want to go ahead and discuss.
Yeah, can you show me as a reminder the agenda?
Yeah, let me see if I can.
I know what I wanted to discuss. I don't know in which order I had them. So basically, it's a summary of all the ongoing activities that I have right now, mostly pending PRs. And I wanted to put it onto the agenda to see whether there is a need to discuss something, well, not quite face to face, but at least live in a meeting. I can also summarize for those who haven't looked at the PRs. That might also be interesting. So the first thing is I looked into stability of our pull Kubernetes unit testing job and the corresponding periodic job. I did that because I have another PR, which is not listed here, where I noticed that these jobs and other unit tests became flaky when I changed something. Well, my other PR, what it does is it changes the API machinery code, which does wait for cache sync, so that wait for cache sync completes quite a bit faster. And it also changes one unit test for device taint eviction, the DRA feature that I'm working on. And that unit test becomes basically CPU bound. It's parallelized. It runs lots of things in parallel, and it does that as quickly as it can without any waits. So that puts more pressure onto other unit tests which run in parallel. And these two things combined, I think, explain why I was seeing more test flakes in pull Kubernetes unit. I then started basically thinking about what CPU requirements and which CPU utilization do we actually have in that job. It's set up with one top level Go test run invocation, and each Go test run basically compiles different packages and runs the different test binaries from those different packages. And that top level parallelism is bounded by the number of CPUs in the container, Go max procs basically. And then in addition, inside each test binary, the test binary itself decides that it can run Go max procs different things in parallel. And overall, if all unit tests are CPU bound and completely occupy all CPUs in the system, we are overloading the available number of CPUs. Mostly that seems to be fine currently, because unit tests, in particular, also some of the long-running ones, they tend to wait for things. They tend to wait for cache sync. They wait for other things to happen. So there are some sleeps, and I just basically saw that this current approach no longer works. I tried a few things. This one is the thing that didn't quite work out, but I'm using it to summarize some of the things that I fixed already. So I did get some PRs merged that fix unit tests, which is ultimately the right thing to do. So a unit test should not be dependent on any kind of real world timing. We don't know how fast a CPU is. So anytime you say, well, this activity needs to finish in 5 seconds, it's bound to flake at some point when the timing doesn't work out like you were expecting from your own local machine, for example. Starting with Go 125, we have a way to write timing dependent tests with a new package in Go called sig-test, which virtualizes time. And inside the test, it looks like time really passes in a deterministic fashion, while outside the actual computation, simulation of the time runs as fast as possible. So I've converted a few tests, and these are the merged links here to sig-test. And those tests then became stable, and they sometimes run faster than before, because something that is a time sleep, say for 10 seconds inside a test, executes in no time, no real world time. That makes some of the unit tests quite a bit faster. So yeah, converting unit tests if they flake, I think that's still the best solution, but there could be quite a few of those. And the more unit tests we convert to sig-test, the higher the pressure becomes on the other non-converted unit tests to that they might flake more. So I see a little bit of an arms race coming towards us where we fix one unit test and something else starts to fail. What I was trying here was in this PR was to make converted unit tests, those that don't depend on real world time, that they themselves lower their own priority. So overall, we have a scheduling problem. We have oversubscribed CPUs, and we want to make sure that the binaries that are timing sensitive, that they get priority on CPUs, and everything else can run with lower priority. This PR, this proof of concept here, does that from inside the converted test binary. So a test binary can say in its init function, lower my priority. There is one test in particular, some filter something somewhere, which runs for, I think, 2 minutes using all CPUs in the system. I don't know what it does, but it churns through a lot of things, basically keeping the CPUs completely busy. And this is one likely candidate to say, okay, well, I don't care about timing. I just need CPU time when I can get it. And this CPU test, this test binary could lower its own priority so that if it runs, it doesn't push off other more important unit tests off the CPU. The problem is we don't know which tests need this kind of voluntary lowering of priority. So I was trying to do something with shell scripts that monitor the running job to see and identify tests that are not nice. It's literally the nice command on Linux which lowers priority. So I was looking for CPU intensive unit tests because we also don't have any statistics about that in TestGrid or anywhere. We just have the overall wall clock time, but not the consumed CPU time. So I was trying to get some statistics with Bash. It didn't work out. It was less stable with that Bash monitoring. And at that point, I gave up on that approach. But I at least found it interesting. And since then I learned that there is perhaps a better way to monitor CPU consumption. Go test has a flag called exec, and you can specify a wrapper binary. You can say go test exec some wrapper that we are writing, and that wrapper invokes the actual test binary, and it then can do things like getting the CPU time of the wrapped binary and do something with it. I haven't explored that further, but it might be a better approach than the bash monitoring that I was doing before. I might come back to it. Anyway, this PR, this proof of concept, is probably just something that I'm going to close. The more interesting one is the one that I have pending. So if you go back to the agenda, the make, test, compile under nice, that is something that I found useful. Jordan correctly asked me some further down in the PR review whether I can prove that it's useful. And that's a bit harder. I have anecdotal evidence that it helped in my other pending PR, which is actually here at the bottom of the screen. But I need to do more runs with, that one. I need to do more runs in that PR with and without this test nice PR to actually have some more data, like say 5 runs with that PR, get the flake rate, 5 runs without it, and perhaps get more flakes. If that may help to get that PR merge. But I think overall so far it's looking like this is something that can be done, that should be done. What this other PR does is it uses another wrapper thing for compilation. There is Go tool exec. So like the exec that I just mentioned, tool exec can wrap the Go compilation, the compiler, the linker, and I'm using that to inject nice into the invocation. So the effect is that all the Go tooling, which also competes with running test binaries for CPU time, runs with nice. And I think that's a fairly low effort thing. It's a 1 or 2 line change in the test sh script, and that I think helps, and it's something that we should be doing because intuitively it makes sense, even if the hard data isn't there. So on that PR, I'm currently gathering a bit more data, but I think it has LGDM, it has approved. It just has a hold that I put onto it, and if I have more data, perhaps I'll share that and then lift the hold, and we can move on. So the summary of this long rant is that things are coming for unit tests that might increase the flake rate. We need to keep an eye on it and, well, see how it goes. In particular, the other PR that I still have pending in API machinery. Once that lands, I'm really interested in seeing flake rate and what kind of problems it causes. Right now, we seem to be okay. We do have flakes also in unit tests, but it's not too bad. But with that pending change, it really became worse. Okay, I guess that was just a summary of things going on, and then the other big thing is Ginkgo E2E tests, the label changes. That's just it's a recap from a Slack discussion that we had. These 3 PRs all built on top of each other. So the first one, this is the first one, that is the building block, the basic thing. And then the others include that PR and add something more. I would like to get them merged in this order because that's basically something that works standalone. And yeah, I don't have Antonio and Ben here. I was mostly discussing it with them. The overall problem that I'm trying to solve is that we are injecting metadata into the test names using special calls in our source code for E2E test registration. And the end result is a long test name in Ginkgo and in TestGrid, where we have in square brackets some of the special labels, sometimes a feature gate label. We have special labels for beta off by default. All of that tends to be it is currently inserted at the place in the next to the text that, or next to the code that adds that particular information. So some of the test names are not very nice because of that. We have some text, some meta tag, some more text, another meta tag, something else again. And I overall find that not very convenient. I sometimes look at TestGrid and all I see is the metadata labels, the meta tags, and not the actual test names. So what I was trying to achieve is that we only have the important information, the actual text from a test at the beginning, and all the metadata gets shuffled to the end of the overall test name. And to do that, I need to make changes. I need to make changes in our E2E framework, how it injects those labels. I need to preserve information from multiple Ginkgo calls. So basically it starts with Ginkgo describe, which may collect some meta information. It continues with Ginkgo context, adding something else to the full test name. And then eventually I get to a Ginkgo it, which describes and finalizes basically a test name. I worked with Onzi on Ginkgo to add a new feature where I can inject basically a hook into the construction of the tests in Ginkgo. And my first PR uses that feature to achieve something which I find useful. So before, if you did what you see in the description, if you did Ginkgo it, some test, and then our framework with slow annotation, it would fail. It would fail because Ginkgo it itself doesn't understand our framework with slow parameter. It has to go through our wrapper that we have in the framework. And people got that wrong. I got it wrong. I convert something, I add a with slow somewhere. It fails during test construction. It's not a big problem. It's just a paper card, and it's annoying. And now it's no longer necessary. We can do better than that, and that's this PR here. So I find it useful. And in addition, it enables the other changes, because once I know that all test construction goes through my hook, I can say, well, in a Ginkgo context call, you have a with slow, and that's fine. I'm going to see that with slow parameter in my hook, and I can push it to the end of the metadata later on. I can't do that if I don't get this PR merged. If I don't switch to the hook approach to injecting or to handling our special labels, then I don't have any guarantee that I get to see all the special things. That's part of the motivation, but ultimately it's also about what do we expect developers to do? I don't want them. If I could go back in time, I wouldn't even have introduced the wrappers. I would just make it so that Ginkgo it is the thing to use, and not create the confusion in the first place. Yeah, I hope it makes sense. Antonio isn't here. He had questions. He wasn't sure whether that's worthwhile, and he didn't want the dependency on Ginkgo. But we already depend on Ginkgo. So I don't see that as a valid objection. It's just different. The second PR then does what I just described. It collects all the special information in all the calls that lead up to the final Ginkgo it, and then in Ginkgo it, I add all the collected things at the end. It is a bit hard to review because it changes basically all the test names. So if you do a diff, I think I have it somewhere. Uh, yeah, it's just a lot of things to review on. And it actually I don't remember why it touches all these files. I need to go back to it, but it's dependent on the other thing. So if I can't even get the other thing merged, we're dead in the water. And the last PR is finally doing the thing that this all started with. We have in feature gates since last release the ability to define feature gate dependencies. So if you have, say, for example, a DRA example is DRA extended resources. It's a feature that depends on the core DRA. And this dependency is now defined inside the feature gate definitions. And we wanted to make that visible in our test names, but it just adds more of those meta tags. And it does those in the middle of your test name, which makes this whole problem that I just described earlier, where the full test name isn't very readable, it makes it worse because we get more metadata inserted in the middle. And therefore, I think we should do the other thing first. We should make sure that the meta tags appear at the end. And then if we add a few more of those, it doesn't really matter that much. It's fine if it's at the end. Then if you look at the test grid, you see the relevant information first, and at the end you have the things that are less interesting for a human. Yeah, but that's down the road. I still need to get PRs merged to even get there. I think that's what I had.
Well, thanks for sharing that. Does anybody have comments before we move on? Cool. I don't know if I'm missing Yeah, I'm probably missing precision on the right. Mohammed, are you here?
Hey, I am, yes.
Cool. I think the next bit is yours.
Yes, so hi everybody. I put together a mini doc that I want to put in an email to KDev. So I'm soliciting some feedback from testing. So if you could open the document on the last tab.
Should be open. Is it not showing?
Yep, this one here.
Okay, cool.
Basically, yeah, this doc here. So there's a couple items here, basically interesting. So I want the community to effectively fix up their proud jobs. There's a section there about use the right image. We're still seeing images not being used correctly. That causes some problems in December when Docker decided to break something in v0.29. So that's that. I'm also looking to announce deprecation of kubectl v1 and actually stop its usage unless we need it. That image should only be used if you're doing GCE testing because it rolls in a lot of CI craft from Kubernetes test infra. All the other jobs don't rely on anything from Kubernetes test infra. So they really should be using the new image that I built like 2 years ago, which we are using for all the jobs that are require different architectures. etcd uses it a lot. We use it in cops and we use it in a few other places. We want that to be the primary ERE image that everybody runs because it has all the tools you need, and yeah, it works. The other call out I wanted to make was people really need to build multi-arch images and binaries for everything. We do build it for, I'm especially looking at sub-projects. I even had to add ARM64 builds to something in Kubernetes that's used widely as recently as last month, which was kind of surprising. So this is another call out for people to actually do it and to also build against those four architectures that we support, that we officially support. One of the things I noticed that was blocking people from building it correctly is you have to faff about with build X and Kimu and that stuff. So The image that we have for the image that we recommend using in the cloud build supports out the box now. So I've made some changes to it. So you don't need to think about it. You just run Docker build and you specify all the platforms that you're supposed to specify and you pass Docker file, it just works. Today you need to, well, before that change, you had to do some additional bootstrapping, which now disappears if you use the tool chain that we offer, right? So that's the second item. The third item is we have a new build cluster available. We deployed it last year, but we never got it working. So I revamped it and fixed it now with the new name. Also, this cluster is kind of special because it officially has dual stack networking. So when your test pod spawns, it will have an IPv6 address and it should work. One of the things I did put in here that's a little bit contentious is that we do want to make all the other clusters dual stack too. So I need to figure out, okay, what's going to break if you do that? And so it's a wider feedback and see how that goes. Another big item of mine is right sizing projects. So if you open these dashboards in Grafana, especially the GKE one, if you put that link there for a second, yeah, that one. Yep. If you scroll down a little bit, if you look at resource usage for just Kubernetes, or even that little box in the corner, you see we hardly use any of the CPU that we need, that we request, right? So jobs are over provisioned, like a really big factor. If you expand that bottom table there at the bottom, resource, where it says resource, yeah, there we go. The green line is actually what the system is reporting as being used. The blue line is what we're requesting, and it's a factor of five at times, at least from 3 to 5x, depending on what's running. We really should close that gap. And so it's a PSA to everybody to, hey, double check your resource usage. We did this exercise 2 years ago, but it needs to be something we do periodically. So
I
that's
like I
that
like to
one.
add that the unit test actually, I think, fully utilizes all CPUs that it has reserved for it. So this is one of the jobs that basically is CPU bound and
I
really,
have something for you that will be interesting. So if you go back to the
I, or at least I saw peaks. I did not actually scroll in. That might have been my problem.
yeah,
I wanted
I have something for you. So one of
yeah,
the
okay.
reasons why some jobs, particularly kind and unit tests, are over provisioned is they don't like noisy neighbors.
Yeah.
So hey, we have affinity and anti-affinity concept. So why don't we use that and right size the test pod correctly, but guarantee that there's not another neighbor next to you? Because for us, it's very easy to spin up a node and get rid of it after it's being used, right? So yeah, so we're also introducing that feature in this new cluster. So we want to test it out there, see how that goes. So there are two new things we want to trial on this cluster, which is hey, instead of specifying resources directly, hey, there's a magic label. You tell us the sizes, it's prefixed. We'll insert it for you when the pod spawns, right? And also, if you do specify this sole tenancy label, we will schedule a test pod, even if it's a very tiny one, like 2 cores or 4 gigs, on a full node that's like maybe 3 times that big. And we guarantee that another prod pod won't run on that thing during the lifetime of the test. So that should eventually allow us to right size the unit tests, for example. There's no reason why the unit test needs 7 cores and like 20 gigs of RAM, right? It was using as high as 40 recently. I capped that down to
Well,
25, right? And it still works very well.
yeah, but it should be able to utilize all CPUs that it can get.
Yeah, but also
And
at the same
then
time, what happens if you instead of using 7 cores, I gave you 4 cores? Like, what would happen? It would just be slower, right?
it would run longer. Yes. Yes.
Yeah, but how long should it run? This is the fun question.
Well, yes, it runs pretty fast. It's 15 or 16 minutes right now, so it doesn't need to be faster. It just needs to be stable, and that is the bigger challenge. Yeah.
No, we have a solution for the stability. Let's right size it and also force that it runs on its own node.
Yeah.
No neighbors. We
So
also
is
eventually will
is
get a
that
list
is
of all the jobs that behave like that. Right now, nobody really knows unless you're an insider
yeah.
on what jobs are actually that require sole tenancy.
Is it You said you right size it. I saw that. Is it currently running alone on a node? Is it the sole tenant?
Right now it is because we max out the CPU. So we assign it 7
Okay.
cores on a
Yeah,
node that only has 8
okay,
cores.
good. Yeah. I
Right?
think that's what we want. We want basically the stability. We could
Instead,
have,
I would love
yeah,
it if you had 4 cores and like 60, like slightly less RAM, but it was guaranteed to run on its own node. So we'd actually get the real usage that we actually need.
yeah.
Plus the stability of being on a sole Kubernetes node and there's nothing else on there. Because right now the resource size masks that requirement.
Yeah. But if it, well, now it gets a full node and it doesn't allocate all memory, but the rest of the memory is then just basically unused, right?
Yes.
It's that's fine. I think right sizing is still the right approach so that we know what it needs.
Yeah.
I just don't see a practical implication right now.
Well, right, the good feature is, hey, we know that, hey, we have a small subset of jobs that do that, right? Instead of every job that ever copied the unit test behaving like that when it doesn't need to.
Yeah.
Right.
Yeah, that makes sense. Anyway.
And the jobs that look like this, we'll know what they are. We'll review them periodically. Be like, hey, do you still need this self-tenancy thing or not?
Yeah.
Quick question also, like the extra time taken for the unit test is acceptable because it's not the blocker in terms of time, right? It's like, I don't know if
I
15
know.
minutes still sounds kind of long.
Well, we are struggling with 1 hour test runs for test integration. Oh,
That's kind of what I figured. Yeah. Okay, cool. So like maybe
ah,
later
half,
down the line that becomes like not, or that if we can have the unit test be the bottleneck and then increase the speed of them, like great, but that is not anywhere close to the problem right now.
Also, we don't want to give it more resources. We just want people to fix the functional bugs, right? Right. If I give it more resources, it will hide the actual problem, right?
yes. Ultimately, we want it to be stable regardless of how many resources it has. So at least for unit tests, I would argue that it absolutely should be stable under any kind of timing condition on any machine, no matter how fast the CPU, how many cores. It's just that we are not there right now. Some of the
I
unit tests
agree.
are sensitive and they shouldn't be, but yeah, getting
You
all of
know,
them fixed at once is just not possible.
I agree with you.
That's fair, yeah.
So I think this approach will let us know, okay, hey, all these jobs have a functional requirement. They're not big because we want them to be big, but we made them big to meet this requirement. Now we right size it, put this label in, we know what they are, and it's an action item for everyone to figure out, okay, hey, we have a bunch of salt tenant pods. Why are they like that? What can we do to make it better? And they just sit there. Yeah, so that's that one. So the idea of basically the resource sizing is, hey, a lot of people arbitrarily pick values, right? Most CI providers give you like, hey, here's a fixed size, pick one that suits you, okay? And this is what we're trying to implement. We will be injecting pods dynamically to insert these values. Um, yeah, there's some details on the issue that's linked at the bottom of that section. Uh, but yeah, we're gonna try that out, see how it goes. If we like it, we'll roll it out to the GKE and the EKS clusters. If you scroll down a little bit, yeah, I think that IPv6 one might cause people to, hey, I have some opinions on that. So the idea is I want to put that announcement out there, open an issue, and get everybody to comment on it. Okay, what's the actual problem? And see if we can get it fixed. Um,
Yeah, your docker looks nice. I just remembered that I did something similar, drafting up an email about testing and how to write test jobs. If I just can find the chat, I could post it, but where's my chat window? There it is. I wrote something from a sig test, a bit more oriented towards sig testing, how to write brow jobs and how to maintain them. some other best practices. It's kind of complementary to what you described. So some of the things that I had in my list were, well, use Ginkgo labels. First thing. Kubetest 2 migration was another topic. I think Ben brought that up. Migrating away from Cube up SH and Bootstrap Pi. Another thing, testing of release branches. One observation that I had is that many jobs that we are using to test features on master are not getting forked for releases, simply because the job owners forgot to add the necessary annotations. So test coverage in our release, in our stable releases, is much less complete than what we're testing on master, which is kind of okay because we also only backport critical things, but still, it's not what it should be. I'm basically now going through my document, and then
Yeah, I looked at the document actually, so it has some pointers that I wanted to discuss in a separate mail thread.
Yeah,
I've been working with the
that
IBM team figuring out like,
yeah,
hey, so since we did the shared jobs last year, I wanted to put together, hey, here's a list of here's how you test Kubernetes, right? I am somebody who's building a distro. Okay, great. Look at this list. Make sure you have these jobs present in your
yeah,
on your distro, Sienna, whatever build pair you're trying to build, right? And have that prescriptive approach for everybody. Because I got asked about that by a few people. So I've been working with the IBM team. We have some of this stuff running, but not the full set.
yeah.
And it's partly
I brought
because we
yeah.
don't have a doc for it.
Yeah,
So we need.
I brought up my document, my draft email because I never sent it out because Ben thought it was too long, and yours is even longer. So who's go? And serious, it's worthwhile to put that in front of people. But how do we make sure that they actually read it? How do we get the information across if that was in an email? I don't know. It's really an open question. I think the suggestion from Ben was to split it up, send one email per topic or per item. I do not necessarily agree because then it's less complete. I just don't know. I don't have any objection against sending such an email. I would read it. I don't know about others.
Yeah, I don't have a good answer either, other than send the email, see what lands,
Yeah,
and
right.
then slowly chip away at the things. I've been trying to work on some of the things that you've got in your doc for 3 years, and we're slowly getting there. It's just like it takes forever.
Yeah. Well, some of the things are things that other people should be doing,
Oh
like
yeah, that's the problem.
the forking of jobs. This is just something people need to know, and they don't, and we need to educate them and remind them or whatever. I don't know. Yeah.
Well, that's owned by Sig Release, to be honest. But the problem is you need to give Sig Release a doc that says, hey, for a given release, these are all the things we need to run.
No, I think the forking it's done by sig release, but the job owners need to configure it.
Oh yeah.
Yeah.
Well, for the shared jobs, that's us. So we put the labels on there and we
Yes,
take
and I
that.
think we've done that, but I know for some of Signode jobs, for example, there's barely any forking for releases. And that's something that Signode needs to fix. Just picking one
Okay.
sig that I happen to know a little bit about. And they also have a lot of jobs, but that's another topic. Anyway, I have no objections against your email. I don't know, well, it's getting late now, but I don't know. When do you want to send it?
I want to send it early next week as the release
Yeah.
kicks off.
Yeah. I can go through the doc tomorrow and see whether I can spot anything that I haven't seen yet in the call, but overall, I'm fine with it. You probably want to run past Ben and at least Ben, perhaps, I guess, right?
Yeah, I'm gonna talk to Ben, Dames, and a few other people, plus my own
Yeah.
sig.
Yeah.
And yeah.
I think my main feedback would just be I think the points called out here are good. So my two questions are, should any of these make their way into like documentation of some sort? I know there were
Oh,
some.
yes, they are.
Okay, cool.
So for example, I have an open PR to update what a cloud build job should look like. It references the new image and it tells people don't remove the entry point and and these are the features of using this image, right? Right now, the cloud build doc is pretty bad. So it still has a single arch build instructions. And yeah, that's not gonna work anymore. Um, and so now there's only exactly one description, and it says, "Oh, use our image, call a make target that does Docker build, blah blah, whatever, right?" Uh, and yeah,
I think the second bit then is just like a little bit more of a TLDR and summarization near the top, just because like I also agree that emails tend not to get read doubly so the longer they get, and while the info is good, I think also having like a couple call outs at the beginning for folks who are skimming like the top of it is like hopefully a good balance of people can read the detail when they absorb it, and if not, they'll at least get something out of seeing this.
okay, so what I can do is I could put a section there, TLDR, and the TLDR would just link the documents that were updated, right? We've updated these documents. Please read them. This is the latest instructions. And the section underneath it, which is action items with a couple of bullet points, and then the body of this entire message after it.
Yeah, I think that'd be good, especially because it's like the biggest things to me seem to be relevant if you are maintaining jobs, writing jobs, which should be a lot of people, and then image builds and like calling out those three things specifically so that people know to reference this doc or like the sorry, this email or the updated doc seem worthwhile.
Okay, yeah, I'll do that.
Cool. All right. Anything else on this? Sounds good. Thanks, Mohammed. Last item I think is Brady, you had a quick call out?
Hey, yes, sorry. This is really just a reminder for myself and Michelle. We need to get back to the Prow user survey that we plan on sending out. I think we're a little bit behind on that, as well as any new contributors. If you're interested in both Prow and Test Grid, they're two projects that are pretty integral to what we do, and they both need new contributions. So, yeah, thank you. That's it.
Very quick thing on the test grid UI as well. I think the remaining big stuff to do, one of them should be unblocked now. I added a new thing to the API and I will be pushing it to prod today to unblock some of the features that couldn't be done until like some more information was exposed to the API. I will see if there's any other things that need to be changed, but that should be like the major unblocker. The other one is, I think, Mohammed, you pointed out performance is pretty slow on the new UI. That is a general thing to fix, especially for, I believe we still have existing performance issues as well for displaying large tabs, which will not be fixed by the new UI yet.
Yeah, I have some comments on test grid as well. So yeah, it's now deployed. I have a question about why did we decide to do client-side rendering? It's pretty slow, especially in my part of the world. I'm not in Europe or in the US, so yeah, it's not fun. Um, so what happens now is you load the UI. Your client will make an API call to test grid. It will fetch everything, and then it will generate render it on your computer. Um, I think that's a consequence of it being a single page application. But we really should revisit that and do server-side rendering, where the server or the pod that's running the UI makes the API call in the background to the pod right next to it that has the API, pulls the data, and then renders it and sends you the completed render to the client when you pull the UI.
I think we're lacking some of the front-end expertise for like doing that. I don't think there's any particular reason that we would do so unless it was like complicating the like more Like the main aim was to make it one, have the API so that it's like more possible to do things like that and also do like some pre-rendering because the existing way of doing so is even worse actually on the existing UI. Um, and just like have a more modern framework overall for doing this. Aside from like those initial aims, I don't think there's anything preventing us from like doing further changes to try and optimize that. So I think the answer is just lack of expertise and like that's how it was initially done as an improvement over the existing UI.
Okay, let's see what other people say. If we get sustained complaints about the speed, I think that's something that you need to look at.
Yeah.
Yeah.
My understanding also is like there's performance hits probably in several areas. I think that can be tackled probably in parallel or like at the very least performance can be improved on like parts at a time.
Part of the reason why SSR is kind of important is right now, once you build a container, you cannot override the API endpoint at all. It's like it's in the JavaScript files that are like as HTML. So you have to do a full rebuild. So we need to bake the URL into the build process.
Got it. Okay. Yeah. If you haven't already filed an issue for that, I think that's a good one to call out. I know that it was called out in the PR, but
Okay, yeah, I'll do that. Oh, one last thing. Thank you for fixing the permissions. There's one other fix, which is to make that bucket uniform level access, and then we should be good to go.
sorry, the case test grid bucket uniform?
Yes, so I'm using workload identity federation, and it doesn't work on buckets that use ACL. So you need to
That's
you need to convert it to uniform bucket access.
fun.
Okay, so after that fix is done, I will delete the proxy and point the API directly to the pod.
Okay. That one might be a longer change, but I will take a look at it. I just need to make sure it doesn't have any other knock-on effects. But yeah,
Okay.
cool. All right. I think with that, we can call it good. If there are any remaining comments, please speak up now. But otherwise, thanks everybody for joining, and feel free to catch up on the sig-testing Slack or elsewhere. Awesome. Have a good rest of the week.
Bye.
Thank you.
Bye.